Our new chapter is S block elements. It is the 10th chapter of +1. You have a good idea about this S block because in the chapter 3 we discussed it. S block, P block, D block, F block. So what is S block? S block consists of the first and second groups, that is alkali metals and alkaline earth metals. Among the alkali metals, sodium and potassium are abundant, and lithium, rubidium, and cesium have much lower abundance. Francium is a radioactive. Sodium, in the form of sodium chloride, is present. Potassium as potassium chloride, potassium nitrate, KNO3. And if we consider alkaline earth metals, calcium and magnesium rank 5th and 6th in abundance. Calcium in the form of calcium carbonate, marble, calcium carbonate, gypsum, calcium sulfate. No. Magnesium as Epsom, MgSO4. So they are abundant, but strontium and barium have much lower abundance. Beryllium is rare and radium is the rarest of all. And radium is radioactive also, you know it. And we can discuss some peculiarities of group 1 elements, alkali metals. Alkali metals are lithium, sodium, potassium, rubidium, cesium, francium. Electronic configuration, they are general electronic configuration NS1. Lithium 1s2, 2s1, sodium 1s2, 2s2, 2p6, 3s1. In that way, general electronic configuration is NS1. Atomic and ionic radii, as we move down the group, atomic and ionic radii decreases. And the alkali metals, alkali metal atom have the largest size in a particular period of the periodic table. As we move from left to right, the size decreases. So the biggest atom is the atom of alkali metal. Ionization enthalpy. The ionization enthalpies of alkali metals are considerably low and decrease down the group. We discussed all these things in the chapter 3. So just read and understand. Hydration enthalpy, it is a new term for you. The hydration enthalpies of alkali metal ions decrease with increase in ionic size. Li plus has a higher hydration enthalpy than Na plus, just higher hydration enthalpy than Hk plus, just more than Rb plus, rubidium plus, just more than cesium plus. So in the chapter thermodynamics, we discussed what is hydration enthalpy. An ion in the gaseous state, when dissolves in a solvent, it will be surrounded by the solvent molecule. And hydration, the solvent is water, and the gaseous ion, when surrounded by gaseous molecules, or when forms bond with the water molecules, the enthalpy change, that is hydration enthalpy. Li plus has maximum degree of hydration, and for this reason, lithium salts are mostly hydrated. LiCl2H2, an example, LiCl2H2. It is due to the large hydration enthalpy of Li plus ions. Are the physical properties of alkali metals. Alkali metals are silvery, white, soft, and light metals. They are very soft. It is possible to cut them with a knife. The melting and boiling points of the alkali metals are low, indicating weak metallic bond. They releases only one electron. One atom releases one electron. So the metallic bond is weak. The alkali metals and their salts imparted characteristic color to the flame, non-luminous flame. Lithium imparts crimson red color, sodium gives yellow color, potassium violet color, rubidium red violet, and cesium imparts blue color to the flame. Chemical properties. The first one, reactivity towards air. All the alkali metals react vigorously with air. Actually, they will burn in air. And to form oxides, lithium forms only monoxide. Sodium forms peroxide, Na2O2. Lithium Li2O2. The equation is given here. For Li plus O2 gives 2Li2O. Lithium oxide. Sodium forms peroxide. 2Na plus O2 gives Na2O2. But the other metals of the alkali group, alkali metals, forms superoxides. K plus O2 gives KO2. Potassium superoxide. Now here you can see a question. What is the oxidation state of potassium in KO2? Oxidation state of potassium is always +1. It has no change. So oxidation state of potassium is +1, but that of oxygen is -1/2. We discussed it in the chapter redox reactions. Reactivity towards water. All these elements react vigorously with water also. They are, for example, sodium reacts with water vigorously. Sodium metal run over the water with the fire. Such a strong reaction. The alkali metals react with the water to form hydroxyl and dihydrogen. An example, 2Na plus 2H2O gives 2NaOH plus H2. Because of their high reactivity towards air and water, alkali metals are normally kept in kerosene oil. I studied it earlier. Although lithium has most negative E0 value, E0 value means electrode potential, standard electrode potential. The chapter redox reactions, we discussed it. Its reaction with the water is less vigorous than that of sodium, which has the least negative E0 value among the alkali metals. As the electrode potential increases the reactivity, the negative value of electrode potential increases, the reactivity increases. And lithium has the most negative E0 value. So we are expecting more reactivity for lithium. But when we consider reactivity towards water, lithium is least reactive. But which has the least negative E0 value? Sodium has. Even the sodium is more reactive than lithium towards water. Why? Because of the small size of lithium and very high hydration enthalpy. Our reactivity towards metals, reactivity towards hydrogen. These metals react readily with the hydrogen to form ionic hydrides. And the temperature is, the reaction temperature is 673 Kelvin. An example, M represent alkali metal. 2M plus H2 gives 2MH, ionic hydride. Reaction with the halogens. The alkali metals react readily and vigorously with the halogens to form ionic halides. Na plus Cl2 gives NaCl. You know the reactions. Reducing nature. The alkali metals are strong reducing agents. Why? They are highly electropositive. They have the capacity to give electrons. Therefore, alkali metals are strong reducing agent. Lithium being the most and sodium the least powerful. The most powerful reducing agent among alkali metal, lithium. And the least powerful reducing agent among alkali metal, sodium. Keep it in your mind. Now a question for you. The E0 of Cl2 bar Cl minus is plus 1.36. I2 bar I minus is plus 0.53. Ag plus bar Ag plus 0.79. Na plus bar Na is minus 2.71. And for Li plus bar Li is minus 3.04. Arrange the following ionic species in decreasing order of the reducing strength. You know, reducing strength increases with the increase in the negative value of electrode potential. Increase in the value of negative value of electrode potential. Which is having the largest negative value of electrode potential? Lithium. So first lithium, then comes sodium, then iodine, silver, and chlorine. That is the order given here. Another important reaction with the liquid ammonia. Liquid ammonia can act as a solvent. The alkali metals dissolve in liquid ammonia, giving deep blue solutions which are conducting in nature. So when alkali metals dissolves in ammonia, we'll get a deep blue solution. And that deep blue solution conducting in nature. So if we analyze it, we can understand the reaction is M. M means metal, sodium, potassium, rubidium, or Cc. M plus X plus Y NH3. Not certain about the number, so it is written as X plus Y NH3 gives M NH3 X times plus E NH3 Y times minus. Metal gives one electron and it will change it to M plus and E minus. This M plus will form bonds with NH3 and we cannot predict how many molecules of NH3. So we represent it as X. M NH3 X times plus. NH3 is neutral, so charge on the metal will remain as plus. So M NH3 X times plus plus E NH3 Y times minus. Released electron also forms bonds with the molecules of NH3. We cannot say how many, so written as Y. The blue color of the solution is due to the ammoniated electron represented as ENH3Y times minus. That electrons are free to move. And that electrons can be excited. The ammoniated electron, which absorbs energy in the visible region of light and thus impart blue color to the solution. Because of these electrons, the solutions are paramagnetic and on standing slowly liberate hydrogen, resulting in the formation of amide. M plus electron plus NH3 gives MNH2 amide, NaNH2 sodamide, MNH2 plus half H2 with the liberation of hydrogen. So here, why there is blue color for this solution? Because of the solvated electrons. That means ammoniated electron. Why it is conducting electricity? Because of the ammoniated electrons. As it stands, what happens? Slowly, hydrogen liberates and forms amides. Here in bracket Am is given. Am means solution in ammonia. If it is an aqueous solution, when solution in water, we'll write in bracket AQ. Here to represent a solution in ammonia, we'll write in bracket Am. In concentrated solution, the blue color changes to bronze color and becomes diamagnetic. So we already told the solution is paramagnetic even it is blue color. And as the concentration of alkali metal increases, what happens? It will change to bronze color and becomes diamagnetic. Uses of alkali metals. Lithium metal is used to make useful alloys, for example, with lead to make white metal. It is using for bearings, for motor engines, with aluminum to make aircraft parts, and with magnesium to make armor plate. It is used in thermonuclear reactions. Lithium is also used to make electrochemical cells. Liquid sodium metal is used as a coolant in fast breeder nuclear reactors. Potassium has a vital role in biological system. Potassium chloride is used as a fertilizer. Potassium hydroxide is used in the manufacture of soap, soft soap. It is also used as an excellent absorbent of carbon dioxide. In experiments to absorb carbon dioxide, we will use potassium hydroxide solution. Cesium is used in photoelectric cells. So we can use, we can stop here. All of you study it well, and we can see the remaining parts in another class. Okay.